In April 2018, Sudhish Ramesh resigned from his position as a software engineer on Cisco's platform team. His role had given him access to Cisco's AWS infrastructure, specifically the access key for the servers running Cisco's WebEx Teams application. When he left, his official Cisco accounts were disabled. The AWS access key he held was not revoked. 5 months later, on September 24, 2018, Ramesh connected to Cisco's AWS infrastructure from his personal Google Cloud account and deployed code that deleted 456 virtual machines. More than 16,000 WebEx Teams accounts went down. They stayed down for up to 2 weeks. Cisco spent approximately $1.4 million on remediation and refunded over $1 million to affected customers. The access Ramesh used had been legitimate when he worked at Cisco. His role required it. His departure did not end it. That gap between when the need for access ended and when the access itself ended is what the 5 months represents. The offboarding process closed his official accounts. The AWS key he held as a credential outside that process remained valid, remained usable, and remained his. Offboarding processes are designed around the identity provider. They disable the central account, the directory entry, the SSO identity, the record that governs federated access. When that account is disabled, the access it directly controls ends. The access it never knew about does not. In a modern environment, a single employee's tenure generates credentials across dozens of systems, most of them outside the identity provider's visibility. An AWS IAM user created for a specific project, GitHub personal access tokens generated during a repository migration, API keys registered in third-party services under a work email, OAuth grants approved during integration work, service accounts created on a team's infrastructure and never tied back to the central directory. Each of these was created for a legitimate reason. Each lives independently of the central account that offboarding revoked. Call this the offboarding gap. It is not a failure of the offboarding process to do its job. It is a structural limitation of processes designed for a world in which a person's access was a single account in a single directory. That world no longer exists. The offboarding process captures the identity it was built to capture. The distributed credentials it was never told about remain valid. The same pattern governs services. A service is built, deployed, and assigned a service account. The service is deprecated and retired. The team that built it moves on. The service account is not transferred to any current owner, is not included in any active inventory, and is not monitored because it generates no activity. Nobody will revoke it because nobody currently knows to look for it. The credential remains valid. It authenticates to the systems it was originally granted access to. It holds the permissions it was assigned when the service was active. It waits. In October 2024, security researchers notified the Internet Archive that a Zendesk API token had been found exposed in a GitLab repository. The token granted access to the archive's customer support system. The archive had received the warning. The token had not been rotated. Attackers used it to access the support system and send messages to hundreds of thousands of archive users. The credential was not orphaned in the strict sense. The Zendesk account was still in active use, but the token's lifecycle had not been managed. The knowledge that it was compromised had not produced the action that knowledge required. The residual access window, the period between when a credential should no longer be trusted and when it is actually revoked, remained open long enough to be exploited. Both mechanisms produce the same structural outcome: access that persists beyond the identity or purpose that justified it. The difference is only in how the gap was created. In the Cisco case, nobody knew the credential still existed. In the Internet Archive case, someone knew, and the revocation was not completed in time. Both produced access that should not have been possible. Governance processes are built around known identities. Orphaned permissions fail this test by construction. An orphaned credential has no owner to respond to a quarterly access review. It has no expected activity pattern against which anomalous behaviour can be detected. A credential that has been dormant for months and then suddenly becomes active is more difficult to catch than one generating continuous unusual activity, and many environments do not specifically monitor for the signature of a long-dormant credential resuming use. The orphaned permission is invisible not because it is well hidden, but because the governance model was never designed to see it. The structural reason orphaned permissions accumulate is the same asymmetry that appears throughout this series in different forms. Creating a credential takes seconds. Discovering and revoking every credential associated with a departing employee or a decommissioned service requires an inventory that was never built and a process that runs continuously rather than quarterly. The asymmetry between creation and revocation means that in any environment with sufficient operational history, the set of valid credentials exceeds the set of governed credentials. The gap between them is the orphaned layer. It grows by default and shrinks only through deliberate effort to find and close it. IBM's Cost of a Data Breach report identifies compromised credentials as the most common initial attack vector, present in 16% of breaches. Not all of those involve orphaned access, but the pattern of credentials that outlive their intended lifecycle, former employee accounts partially deprovisioned, service accounts that survived the services they were created for, tokens that remained valid past every deadline for their revocation, runs through the breach landscape consistently enough that every major security research program documents it. Every permission in an environment was created for a reason. Not every permission ends when that reason does. The gap between those two facts is the residual access problem. Orphaned permissions are invisible to access reviews that depend on owners, silent to anomaly detection systems that look for unusual activity, absent from the inventory that offboarding processes revoke against, and present in the environment regardless. The access has no owner, the review has no recipient, the process has no trigger. It simply continues until someone who was not supposed to have it finds it and uses it.